Welcome everyone to a special performance clinic, part of my season Cloud Automation Unlimited. Today's topic, metric expressions, calculations within metric selectors. I'm Andy Grebner, and with me, Philipp Stadler. Hi, Philipp.
Hi, thanks, Andy, for the nice introduction.
Yeah.
So I'm Philipp, as you said. I work with the metrics team at Dynatrace, and I've been responsible for the last few months to developing the latest feature for metric selectors, which is called metric expressions.
Nice.
And that will take metric selectors to the next level and unlock new possibilities that I would like to share with you today.
Yeah, and I saw you at an internal dev to dev, and this is why I said I want you on this clinic, because I think what you have been showing there and what you've actually been building as a product team is super impressive and also will make the life of our users so much easier. This is why, please, go ahead, show us more about metric expressions.
Thanks. Yeah, it's a pleasure to be here. Let's jump right in. So we'll start with the structure of my presentation today. So not everyone who watches this will have worked with metrics extensively. So we're gonna start with a quick refresher. What even is a metric? What is a metric selector? What do you use it for? Can you use it to slice and dice your data? And finally, we're going to jump into this new and exciting metric expressions and see what we can do with them and see those new possibilities. And finally, we're going to demo all what we learned today and go through some scenarios together.
Perfect.
So let's jump right in. For the first question, what even is a metric? You can imagine it as all the data that you need to draw a line chart, basically. So what we see here, this could be a temperature that we need with temperature sensors. So this would be a classic example of a gauge metric in Dynatrace, something that you measure in a regular interval. So to make an analogy to our CPU metrics, we capture those approximately 6 times a minute, and we could do the same thing for a temperature, then send it to Dynatrace. What is also obvious here that you can measure for each metric more than one thing. And to differentiate what we measure for, the concept that we use is called dimensions, as they're sometimes called splittings. This is what you see down here, these labels for the lines. So to sort out the terminology that we need, let's look at how this data is entering Dynatrace. This is what it looks like. This is the so-called line protocol, what we use to ingest metric data into Dynatrace. And with that, let's look at the structure of a metric. What we see way on the left for the metric ingest is what we call the metric key. This is the unique identifier for each metric, so that we know what the data is associated with, what we're capturing. And now that we have multiple measurements that we need to differentiate, these are the dimensions that we already mentioned. And what it is, it's simple. It's basically a list of key value pairs, and those are important to slice and dice your data. So in this example, I've captured the temperature of some rooms in our office, and also what they're used for, because that's also important for the optimum temperature. And finally, of course, we have our actual data that is associated with our dimensions. And you can also see here with the timestamp, this is not aligned to a minute. You can send in as many measurements as you like for each minute, and Dynatrace will take care of the aggregation. And we're also going to see today how we can influence that aggregation and slice and dice the data.
And I especially like that you bring, let's say, a real world example with a room temperature in a certain office. Clearly the same is, it's the same with any other metric that Dynatrace has, whether it's a host metric, a process, a container metric, a service metric.
Right.
But it's a great way to visualize and bring us a little bit more background on what metrics are and how they work.
Right.
Thank you.
Yeah. A CPU utilization is not that different from a water level or something like that.
Exactly.
Let's start with that. All right. Now we have ingested our data. Of course, we want to get it back out again. And we do that by formulating a query and sending it to Dynatrace. And the tool that we have at our disposal here is called metric selectors, which is this query language that we built especially for metrics, and to transform that metric and extract the relevant parts, gain insights. So let's see what possibilities we have here. Here we have the simplest imaginable metric selector, which is just a metric key. And not very surprising, we get back exactly what we're interested. We have here this line chart with exactly the data that we have seen before. Now, we already said that we can have multiple measurements for each time slot. So you can see here that this is in minute resolution, the finest resolution that we have available at Dynatrace. Now, if we want to see if the temperature is not too high for our employees to be productive, we are more interested in the maximum measurement. So let's extract that with a so-called operator. There it is, the max operator, and it will do just that. And you can see that the scale changed here a bit. This is the maximum measurement.
I guess 30 degrees for some might be considered a little high in an office. And this we're talking about Celsius here. For Fahrenheit for our colleagues in the US.
Yeah, it's funny that you mentioned that. Actually, I prepared an example for that. Okay. So this is not very cold. This is quite hot for an office, actually. Yeah. But let's filter that down a bit. So this can be a bit overwhelming. You can imagine your office might have more than just 4 rooms. So let's reduce that. And what we use for that is the split by operator. You remember that key usage from the ingest data? Yeah. But this is what we see in the line label here. We have aggregated all the data for the kitchens and for the offices. So we have multiple samples here, as many as we have rooms. And from all these samples, we're extracting the maximum measurement, which is relevant for what we want to find out.
And that means by default, if I don't specify the operator, especially the split by, I get a split by the Cartesian product of all the dimensions, or how does that work?
Yeah, you could put it like that. Yeah, it's by default, we have a splitting by all available dimensions. That's right.
And what's also nice here is clearly the kitchen is a little warmer than the office, right? Yeah, somebody's cooking.
Yeah, that's what the kitchen is supposed to be. Right. Now we have symmetric selectors, and we all want to see now what are these metric expressions that I want to show you today. They unlock new possibilities, as we have already established, and I've prepared a few examples for that. For example, what wasn't previously possible with metric selectors was combining the data from separate metrics to gain new data and gain new insights. And one example for that would be, say you have some sort of platform where users can register. Some of them are going to be active users and some not. So you might have one metric that counts just the active users and one that counts all your active registrations. And you can combine the data of the two and find out the amount of inactive users that pose sort of a dead weight for your platform that you might want to keep an eye on. That's one use case. But of course, there's a case to be made for purely numeric transformations. We already talked about Fahrenheit before. That would be one such thing. You might want to convert the currency or even just invert a percentage or ratio. And now you see your first metric expression.
There we go. This is for all of our friends in the US and wherever else they use Fahrenheit.
Right. So these numbers should be more familiar for you. And that's how you achieve it. You can use a metric key as before. It's important that you put it in parentheses. We did it this way because we take backwards compatibility very seriously here at Dynatrace. And we already had keys which contains minuses and plus.
Okay.
And so to be on the safe side, always use parentheses here.
And this also means, and this is a simplified example now with temperature, but here you can really use the full metric selector, as you said earlier, with the split by and everything. Yeah,
absolutely. Yeah. And we're also going to have examples where we combine these approaches with transform operators and with calculations.
Cool.
And the operators you see here, those are just the operators that you're used to from Python or Java or whatever you like to use for your daily work. Right. And I guess you're also interested what happens here under the hood. And especially when you make calculations with multiple metrics, like we have here. For example, this would combine basically the active CPU time. So we often make the division here between CPU time spent in the kernel, which is the system time here, and spent in user space by your program, basically. And this would be only the active time without time spent in idle.
That's really nice.
Right. Let's see what happens here. So you already know what a metric consists of. We have our two metrics here. Each have their dimensions. And with each dimension associated, we have a sequence of time slots. And each time slot has some set of measurements that we can process and also use for arithmetic, as we did here. Now, what actually happens here to generate the new data? We see which dimensions are also present on the other side of the expression. And all of these dimensions, dimension tuples, as we often call it, also make it into the final result of the calculation. And in case you're wondering what happens if there's no partner, so to say, on the other side, then those get left out in the final result.
Okay, so that means if there would not be any metric for one, then they combine it. It's not considered as zero. It's just considered as null, not available, and therefore you also don't get in this case, the sum of the two.
Yeah, that's right, exactly. And now you might be wondering, where can I use these metric selectors? There's lots of places in Dynatrace where you can use them. And the most popular ones probably are our new Data Explorer. I'm going to show you later. And also you can use it in your favorite REST client, or you can use it in your web browser if that's what you prefer for REST APIs. And in the product, you might want to use it to trigger events or alerting. And you could also use it to define service level objectives and Dynatrace extensions and lots of other things. So it really pays off to learn metric selectors, as you'll be able to use them over and over again.
And I think you also kept them simple. I mean, we will see it in the Data Explorer that you built a lot of cool things into that editor where you get, suggestions. Really cool. So it's not that you have to learn a new language. It's really just leverage a very simple thing that is very powerful. Nice.
I'm glad it paid off. We tried to make it look familiar and understandable. And I hope I'm going to show that today. Right. Now let's jump right in. The example that we're going to start with is one that comes up quite often. You have two metrics that count something. In this case, I've prepared two metrics that are also built into Dynatrace, counting for services, the amount of service calls with a successful response and those with an error response. And an important piece of data that we can derive from that is the percentage of service calls that were successful, which we could, for example, use to define a service level objective. So let's try that together. If you go to explore data in Dynatrace, what you're probably facing is the classic custom charting. But today, we're going to switch to the new Data Explorer that you can also use, and which also supports metric selectors that we're going to need here. We're going to jump here to the Code tab, where you can directly insert a metric selector. Okay. You can see here that we have auto-completion. And the two metrics you're going to need is the error count, and also the success count. And we can filter down the data there a bit and run our query. Here we have the metrics separately. But as we said, the important part is in the combination of the two metrics. So let's do just that. Let's disable this too and start with our first metric expression. We want the percentage of successful calls. So let's start with that. Put it in parentheses. And to end up with a ratio, we divide by first the success count again, and then also the error count here. Let's just copy it.
So that's really cool. You can actually do summing up that both counts, like the success count and the total count, and then you're basically dividing it through. Yeah, that's nice.
Exactly.
Yeah.
That's how it works. And humans usually like percentages.
Yeah.
At least for me, it's more easy to make sense of.
Yeah.
So let's scale this by 100, and let's see what comes out. We end up with a percentage.
There you go.
So one service looks good, but we have this easy travel service here, which has a lot of not successful service calls. So this is something that we might have to deal with.
Yeah.
And one way to keep an eye on stuff like that would be to use service level objectives.
Yeah, exactly.
And this is just what we are going to do. We're going to make a service level objective. Easy to do too. We're going to switch in the navigation here to service level objectives. And also we're going to remember that metric key here. There it is, the service level objective here. We're adding a new SLO. Here we again have this nice code editor. We're not going to need the full power yet because we prepared something already. Going to give it a descriptive name too, like success percentage. Then move on. Now, the SLO feature allows us to define the scope where this SLO needs to be in place. And we can do that with an entity selector. So someone from the entity team might come along and also tell you more about that. But for today, I've just prepared one, which is for this one service that we've seen before, that had a bit of a lower success rate than the others. And there it is, it worked. We have our service. We of course can define our thresholds here and define an acceptable range. And that's all the information we need. Here's our expression as we defined it before. Let's save it. And there we have it. You can already see that there's some problem, and you can use that to get notified if some problem pops up.
Perfect. And just for folks that have seen our SLO feature, and what you're showing here is using the matrix expression as part of SLO, which I believe is coming in 2.24, if I'm not mistaken.
That sounds about right.
Exactly, because right now, so folks, if you're watching this like now and you're still on 2.22, being able to reuse metric expression for SLOs and many other things is already on the way to you in production. But this is just phenomenal because it makes things so much easier, so much more powerful. Thank you.
Sure. Now let's move on. I've prepared some more examples for you. This is a situation that you might face when you're using metric expressions. Before in the theory, we saw that we're basically making pairs of tuples that are equal to see which series belongs to which other series. And in this case, we have metrics that count something similar. Both count bytes that have something to do with I/O, but one metric counts the bytes that we read from disk. The other metric counts the bytes that we read from network. And we're interested in how much bytes are spent with I/O. But for some reason, we don't have any data. It's because the dimensionality is different.
Of course, yeah, because on the one side, I mean, I see the host and the disk, and then you have the host and the network, yeah.
Yes, exactly. But we don't have to stop there. We can combine transformations and metric expressions and make the two fit. And we're going to do just that together.
Nice.
So let's go back to the Data Explorer. And let's start with the network bytes. There we have them. The other metric that we're gonna need is the read bytes over the disk, which we have here. And to make them fit, copy them over there. We're gonna need our old friend, the split by operator. And here we can use the dimension keys that we see before. We're gonna split by the host.
And by the way, this is phenomenal as well because the Data Explorer actually gives you IntelliSense, even for the dimensions. So I guess you only get the dimensions, obviously, that make sense for that metric. Yeah. But that's great. And I also like what you do here. I think this is something that I will take home with me. The way you use the code tab, you are putting first your individual metrics that you're interested in as metric A, B, and then build your expression. So you can first individually check every metric, and then you create the expression. That's nice.
Yeah, it's a really useful feature. You can also enable and disable them individually, as we've already done before.
Yeah.
And I've also heard from the Data Explorer guys that they're gonna add some ways so that you can use the other expressions here within your third expression and use something like $A and make it easier to make this combined expression.
Yeah, perfect. That's cool.
Yeah. Now, back to our task. We have now the network byte split by host. And now if we do the same thing for the disk, which also has a host dimension, we can make the two fit. Oh, sorry. So it's almost disk. Almost. Now the two fit. Let's try it out. There we go.
Perfect.
Lots of bytes.
That is great. So that means if you have multiple metrics and they have different dimensions, you can just use the split by to focus on that dimension that they have in common. And then obviously you can do all of your individual arithmetics, whatever you want. Yeah.
Exactly. Yeah. The split by operator is useful in lots of situations. So it lets you aggregate and reduce the data so that you can focus on what's important right now. Right. I wanted to show you that. But Data Explorer and the SLO feature are not the only places where you can use them. Actually, where metric selectors originated, where we first used them, was the metric REST API. And I'm going to show you how to do that. And the metric we're going to look at has the remaining available bytes on disk. And what we're lacking here is the visual hints that we had in the Data Explorer. So when I look at this, something with 10 to the power of 9, I can't really make sense of it at first sight because I'm used to looking at remaining disk space more in powers of 2 than in powers of 10. So let's use the power of metric expressions and make that more readable. All right. This is the REST client that I like to use, but of course you can use just your browser, or you can use whatever metric, whatever REST client you prefer. Important is the endpoint. We're going to use metric query here. It's on the API v2, as you can see here, while the host obviously depends on your Dynatrace instance. Right. And to authenticate to Dynatrace, we're going to use the authorization header. I've already prepared a token here, and which you can generate in a settings screen.
Exactly, and there's obviously a lot of documentation how to use the REST API, to where we explain all of the authorization options.
Then the API itself is relatively simple to use. The only thing that you need to specify is a metric selector, and we're going to do just that. There we have the metric that we mentioned before, available disk space. Let's have a look what we get back. Whoop. Oh, sorry. There we go.
See, this is live.
Obviously. Okay. There's our data, and as in the screenshot, it's high. We can tell that much. But it would help to see it in gigabytes or gigabytes, as some people like to call them. Let's do our calculation. So here we have our metric. We put it in brackets. We divide it. And to make it a power of 2, we'll use 1024. So we have kilobytes, kibibytes, then again, megabytes, finally, gigabytes. Let's try that out. And the values suddenly become more manageable. Yeah, 3 gigabytes doesn't sound like much. We should keep an eye on that.
Very nice. So one thing though, what I want to ask, every expression, even if you have numeric values like your 10, 24, all of these have to go into parentheses?
Yeah, that's correct. That's a limitation because of what we mentioned before. We needed it for backwards compatibility.
Yeah.
Because we did have keys that wouldn't be possible without escaping if we would have left it out. But we are actively looking into how this feature is actually used and if we can drop the parentheses at some point.
Yeah. Okay.
But to be on the safe side, better always use them.
Yeah. Good. And what else is possible? So you showed us the split by, you showed us the aggregations. I think there's a lot of cool other things possible with metric expressions.
Yeah, of course. So there's of course lots of more operators. What you're probably going to use a lot are filters and entity selectors, so that you can really just get the data that you're interested in right now.
Yeah.
You can fill in data gaps, for example.
Yeah.
And yeah, metric expressions for arithmetic with literals and primitive metrics.
Is there some documentation on the metric expression as well, like where we can find more?
Absolutely, yeah. You can have a look at Dynatrace help and get an introduction there.
Nice.
And yeah, we also have a GitHub page with interesting usage scenarios, so we can share a link with that.
Do you want to just quickly maybe put up if you find it? I know this was not.
I didn't really prepare for that.
Yeah, well, sure. Let's see. Right, this is all, we're all friends here. We'll see.
What did we call it? Something with scenarios, I think. So let's see if I have it in the. No, it doesn't look like it. GitHub. There we have it. There we go. It's in the Dynatrace namespace, of course. And if you have the time, please give it a try.
This is great. Yeah,
this will make it clear what is all possible. So, of course, you can also use different data formats. You can list the metrics that are available. Metric API is quite powerful.
Yeah.
So I would really encourage you to give all of that a try, and you'll be a metrics pro in no time.
Yeah. And then I see it here, right? You have from the two. Yeah. So I know you showed it in your REST client. The only thing, the mandatory thing you need is the metric selector.
Absolutely.
Then you have the time selector from and to, where you also have the powerful time selector like now -2 hours or like a timestamp. You can.
That's true. I can certainly show something with that. So you might already know date math expressions.
Yeah.
They're also used by Elasticsearch, and we have a similar implementation. So this operator is pretty neat. It will align your time frame. So this will get you the current day at 0 a.m. I think, right?
Yeah.
It's in the middle of the night. And you can then from there have a time frame that is exactly 3 hours long by adding to that, like that, for example.
That is awesome. So that now/d means midnight, and then d plus 3 hours would be until 3 o'clock in the morning from your local day.
Absolutely, yeah. There's of course more units than that. You might also be interested in the current week, for example. Yeah. You might also want to specify a resolution, a custom one. Yeah. If you're not happy with the one that Dynatrace chose for you.
Yeah. There's also the inf, I know, which we've been using on the captain side.
Yeah.
To get like a single value that is aggregated. If you want to have a single value.
Precisely. It will reduce the data to 1 point, basically, that is valid for the whole time frame. So if you want the average for the current week, what you would use here is inf.
Yeah.
And what I mentioned before with the entity selector, that one you have also seen before. I can specify here some kind of host. For example, if I have a management zone here, I think I even added one called Performance Clinic.
Yeah, exactly.
Let's see if this works. Oh,
yeah, I think without a space, what I saw earlier, maybe.
Okay,
could be.
Yeah,
there we go. Look at that.
There we go. And we've successfully reduced the result a lot. Just the one data point that we get from the inf.
That's great. So do me one more favor, go back to the Data Explorer.
Sure.
Because this is interesting for me. So the Data Explorer, that's, I think, the entry point for most of our users. It's the new charting option, or to explore your data to create charts, create metric expression. Great way to learn the syntax of the query, because we have IntelliSense in there. Play around with it. I really like, as I mentioned before, put your metric, your first metric, your second metric, run the query, validate that the data is there, then do your expression, take it, use it for your API calls that you do with your REST client, use it for instance SLOs. This is also coming soon. I know alerting based on metric expression is also coming, and there's some other cool things coming. Really powerful. Last thing I want to highlight, can you do me a favor and maybe in the first or second expression, just open up the IntelliJ to see what other options are there, because I think the list is quite phenomenal, right? There's like,
yeah, there's lots of ways to transform the data.
Yeah.
For example, if you're interested in the hosts that have read the most bytes from disk, you can combine two operators there. For example, you could do a sorting here,
yeah,
and then sort by value for the maximum over the time frame in descending order. And we said we want the top, let's say 3. We limit it to 3. And there we go.
So that means that this is for me the cool thing, the value operator. You can actually say, you can filter, like in this case, it's part of the sort, but I believe you also you can use the values also for in other scenarios, right?
Absolutely, yeah. We can even use entity selectors here.
In the filter, yeah.
This would be done with an in filter. We're going to use the host, let's say, in this case. And then you already know entity selectors. You can use them here. And then, yeah, could specify a management zone here, for example.
So this is
specific host.
It's very powerful. Now, I know we will have a dedicated session on the Data Explorer. Klaus will come on the show. But Philipp, thank you so much. This was really cool, especially in the beginning when you explained with the room temperature scenario, what does a metric even look like? So if I can repeat, there is always a metric name. There is one or multiple dimensions.
Exactly.
Then you have your individual data points per timestamp. And then basically we are, you can run queries where you can split by dimension. We have all the aggregation features. We're always putting things together per time frame, which is a minute. And then you can do your min, your max, all of the different aggregations, and then the powerful expression language here to get exactly the data that you want. Nice, cool. With this, thanks. And I'm pretty sure, as there's a lot of stuff coming, I will have you back.
Thanks for having me. I'll be glad to be back.
Yeah. See ya. Bye-bye.
See you.